so far you've learned to factorize and then solve equations. You've learned to solve rational equations, linear equations, so many, not necessarily in that order, but you've learned a lot of processes in the meantime, right? So today we're going to pick up with a few methods, specifically a method called the square root method of solving equations. We're going to talk about another method called completing the square method to solve equations. We're going to talk about a third method, which you are very familiar with, called the quadratic formula to solving equations. And then we do some application questions of solving equations. So that's the lesson for today. All right, so let's go ahead and begin with something simple like number 80. Number 80 says that you've got x squared equal to 36, right? And one of the ways that we learned to do this earlier, all right, let's just call it method 1, is to first bring the 36 to the left side, like this, right? And then factorize it using a plus b, a minus b, right? Hopefully we've all become very familiar with that formula. And then solving it. So the two answers are x equals -6 and x is equal to +6, like that. All right. So today we're going to discuss the square root method, all right? And in the square root method, basically what happens is we say, all right, let's take a square root of both the left side and the right side. But when you do something like that, please realize that you have to put a plus or minus before the square root, right? And the square root of x squared is x, and the square root of 36 is 6. So once again, we arrive at the same exact answer. So it's a very convenient method of working with something called the square root method. All right, let's try number 84. Number 84 says that you've got 3x minus 2 whole squared, and it's equal to 4. Now initially you might look at this and be like, wait, what are we supposed to do with that? And here is the incorrect method that a lot of students have taken in the past. And the reason why I call it incorrect is because right now we're trying to learn the square root method. And for them to go through this passage is therefore incorrect because it's not really depicting their ability to use the square root method. So here is the incorrect way students have done this in the past, is they've said, okay, let me write this out as a minus b whole squared, or even worse, a minus b times a minus b. And eventually they come to the conclusion that you have 9x squared minus 12x plus 4, right? And that's equal to 4. And then they say 9x squared minus 12x, bring this 4 over to the left side, is going to give you a 0. Then they're going to factorize out 3x and say that they have 3x minus 4 left over, and then they make the conclusion that either 3x equals 0, and therefore x is equal to 0, or 3x minus 4 is equal to 0, and x is equal to 4/3. So you might be thinking, well, that's kind of weird. You just said that this is all the wrong method, yet you just did the whole problem and you did it correctly, right? So again, this is a technique that I'm trying to teach you here called the square root method. So this is a method of solving this equation, right? This is definitely a method, but it's not the one I'm trying to detail for you right now, okay? So how do you actually go about using the square root method? Well, basically, it's a very simple process. The first thing that you do is you put a square root on the left side, and you put a square root on the right side. And the reason why we're able to do this, please realize, is because there is a square right up here. The moment that you notice it's squared, it doesn't make sense to open it all up again, as we did in this process on the right-hand side. That's too much work. So once you do something like that, you basically end up with 3x minus 2 is equal to plus or minus 2. And then you can move this negative 2 over. Look at how few steps I really need. So it becomes 3x is equal to, that minus 2 becomes a plus 2. So 2 plus or minus 2. And then to divide by 3 will help us solve this problem. So you end up with 2 plus or minus 2 divided by 3, like that. Alright, now we can actually go ahead and solve this problem. The first solution is x is equal to 2 plus 2 divided by 3, which is going to give you 4/3. And the other solution is x is equal to 2 minus 2 divided by 3, which simply gives you 0/3, i.e. it gives you 0. So look at the number of steps that I had to take, alright, and we still arrive at the same exact answer. And much of today's lesson is about going through a secondary process of doing something when you could have done it through another process, but you're trying to find the quickest way to go about doing it. So this is named as the square root method. All right. Now let's go to a much more difficult method. It's called completing the square. Completing the square, we kind of discussed this earlier when we were learning to factorize. And so we've done this time and again. We even did it when we were learning circles in the regular year. So let's go ahead and start simple with completing the square. So first off, you want to realize this is called the completing the square technique. So number 86, all right, we'll go slow with this. The first thing that you do is you write down x squared minus 6x, and then you give yourself some space, and you write down is equal to 13. All right, that's step number 1. Now, step number 2 is you basically need to put an addition sign on the left side and an addition sign on the right side like this, okay? Step number 3 is to take the value of b, right? And when I say the value of b, what I'm referring to is the format ax squared plus bx plus c. You want to take the value of b specifically, all right? So you take the value of b. In this context, that would be the number 6, all right? And it's always going to be the value of b. And you're going to put the value of b up here. Then you're going to divide that by 2. And it's always going to be divided by 2. Okay, so and it's always going to be squared. So whatever is in red, that's always going to happen. The only thing that changes is based on the problem. You just pick out the number that's right here and you place it right over here. That's it. Okay. Now, because this is an equation and you need to balance the equation, you need to put the same exact expression on the right side. So you have to put 6 over 2 squared like this as well. All right. Now, on the left side, here's what you're going to have. You're going to have x squared minus 6x. Now ask yourself, what's 6 divided by 2? 6 divided by 2 is 3. And what's 3 squared? 3 squared is 9. So you end up with 9 on this left side. On the right side, you want to go ahead and evaluate these. See what you would end up with. So you end up with 13 plus 9, which is going to eventually give you 13 plus 9 into 22, like that over there. And on the left side, what you'll notice is you can actually factorize the left side. So you always factorize the left side. You don't move any numbers over. This is what's unique about the completing the square method. So take a look at the left side here. You're going to end up with the same exact factor, guaranteed. So take the number 9. What are the two factors that are going to multiply to 9 yet add up to -6? We all know how to do this. This is going to give you -3 and -3. So in other words, the left side becomes x minus 3 times x minus 3. But here's what's really neat and how it connects to the previous method that I was teaching you, and that's why that previous method is so important. So now you have x minus 3 whole squared is equal to 22. Now what do? Now you take a square root of both sides, right? So at this point, many students say, wait a minute, this is the square root method. Yes, absolutely. That's why you learn that technique, so that when you're doing something like a different method, which is called completing the square, you can still come to a point where you can actually use the square root method, all right? So on the left side, once again, notice how you have a square and a square root, so they're going to cancel each other out. So you're going to end up with x minus 3 on the inside. As far as the root of 22 is concerned, you can't really simplify that, so you're just going to have to keep that guy the way that he is. Now let's move the -3 over to the right side, so it becomes x is equal to +3, right? Plus or minus the root of 22. And you have found your two solutions. You do not need to put this in a calculator whatsoever. This is a completely acceptable answer, and it's recommended that you actually keep it this way, because we like to keep our irrationals, which is, square root of 22, as the way it is because it's the most perfect form of it. If you try converting it into decimals, then it kind of messes it up. So 3 plus the root of 22 and 3 minus the root of 22, those are both your answers to this question. All right. Now let's try something a little bit more challenging. All right. All of completing the square, it's like, if you count it up, it's like 6 or 7 steps. Okay, there's a lot of work there. All right, number 88. It says x squared plus 2/3 x plus 2/3 x minus 1/3 is equal to 0. So remember, I know that you know how to solve this in different ways, right? I get that. That's not the point today. The point is for you to learn a technique called completing the square. Okay, so I'm going to run you again through all of the steps that I took just a moment ago to complete the square. All right, so let's go ahead and get started. Step number 1 is you need to bring the negative 1/3 over to the right side. It can't really be over there. Okay, so it's very unlike the quadratic and how we work with quadratics, even though we're still trying to solve a quadratic in the end. So you end up with x squared plus 2 over 3x, give some space, is equal to positive 1/3, because when that 1/3 comes over, it becomes a positive, right? Now, let's go ahead and pick up exactly where we left off in that previous question, because in that previous question there was already a 13 on the right side. In this question there was a 0 on the right side, so we had to bring the 1/3 over and make it look like what it was in number 86, an x squared term and an x term. So now that it looks like an x squared term and an x term, let's go ahead and start with completing the square. So again, step number 2 in this situation is to go ahead and put an addition sign and an addition sign, and then make a relatively larger bracket, squared divided by 2, squared divided by 2. Sorry, squared divided by 2. All right, so there's that. Now, you're going to go ahead and place the 2/3 in the top. That is the value of b in this situation. So 2/3 goes in the top. Now, if you want to take a moment and ask yourself, what is 2/3 divided by 2? I don't mind at all. That's easy to go wrong with that. So 2/3 divided by 2 is the same thing as 2/3 multiplied by 1 over 2 is the same thing as 1/3, right? In case you missed it, right? In case you missed it. So what we have on the left side here is we've got x squared plus 2/3 x plus 1/3 squared, like that. And on the right side, you have 1/3 plus 1/3 squared, right? Now, let's go ahead and take this left side and make it a little bit simpler. So you'll have x squared plus 2/3 x plus 1 over 9 on the left side. And on the right side, you'll have 1 over 3 plus 1 over 9. And if you work with the fractions on the right side, let's again take a spot over here and talk about this. So 1/3, when you need to add it to 1/9, this is just, small stuff that we don't want to bog us down. So multiply by 3 to get common denominators, and then you end up with 3 plus 1, which is 4 over 9. So you basically get 4 over 9 for that side right there. Okay, so that side is 4 over 9. Whereas on the left side, we're still working with it. Now you're probably thinking to yourself, wait a minute, how in the world am I supposed to think of two numbers that are going to multiply to 1/9, right? Yet they're going to add up to 2/3. It's a lot simpler than you think. Okay, it's a lot simpler than you think. Think of two numbers that would multiply to 9, right, and add up, that would multiply to 9. Well, that would just be 3 and 3. So what about 1/9? Well, that can only be 1/3 and 1/3. And the big hint is they need to be the same number. Okay, in the completing the square method, you're always going to have the same number every time. Okay, so it's the same number that multiplies to itself. So really, you end up with, on the left side, x plus 1/3 and x plus 1/3. I forgot to say this, but do you realize that 1/3 plus 1/3 does give you 2/3, so it does work out for you, okay? Again, then you can say, wait a minute, x plus 1/3 times x plus 1/3 is the same thing as x plus 1/3 whole squared. So now it looks like this over here. Again, we are at this juncture where you can say, now I can use the square root method, and the reason why, I'll repeat for the 4th time, you can use the square root method is because this is squared, and so a square root would be most appropriate, all right? So now, when you square root that, you end up with x plus 1/3, like this, and on the right side, you end up with plus or minus. Now, again, let's take a moment. What's the square root of 4 over 9? Square root of 4 over 9 is square root of 4 over the square root of 9, which is the same thing as 2/3. So really, what goes in this spot right here is 2/3. Okay? Now, similar to the last situation, we're going to solve for those two answers that you would get in this situation. Bring that 1/3 over to the right side, so it'll become a negative 1/3. So you'll have x is equal to negative 1/3 added to 2/3. And then you'll get x is equal to negative 1/3 subtract 2/3, like this, okay? In that leftmost scenario, you'll end up with negative 1 plus 2, which is 1. So the first answer is 1/3, and the second answer is negative 3 over 3, which is actually a very nice, neat answer, is negative 1. Now, completing the square has never been easy for students. It takes a lot of steps. But it is something that you absolutely need when you move into higher level mathematics. So it's not something that's optional, and you can be like, well, if I don't understand it, then that's okay, because I have other methods of completing it. You do need to know that particular method for stuff that's not going to show up until some time from now, but when it shows up, it's a whole lot of it, and then it gets really frustrating to sit there and try to figure out what to do at that point. All right, let's try one more just to kind of drive this point home, right? Even though these take quite a while and we have a bit of a lesson ahead of us, but might as well. So number 90, it says you've got 2x squared minus 3x plus 1. All right, first thing that we're going to do here is we're going to remove the 2 from the front by dividing by 2. You need to do that step absolutely. That step needs to happen. Okay, sorry, I forgot to write the whole problem. So it's equal to 0, and then divide that by 2. So you must divide by 2. So when you do that homework problem where you got the 3 there, make sure that you divide out by the 3. Okay, so must divide by a on x squared from ax squared if a is not equal to 1, of course. All right, so you got to do that step, and I'll show you in the end why that was important if I get some time, but that's an additional step, and that's why we're doing number 90s, because in number 86 and number 88, x squared was simply having a coefficient of 1. Now x squared has a coefficient of 2, so you had to do this additional step, which only makes things a little bit crazier, quite honestly. All right, so now on that front term, you've got an x squared. Then you've got a 3 over 2x. Let me write it like this. And then we're going to move this half over to the right side. So it'll become negative half, like this. And notice that that 0 divided by 2 would have given you 0. Okay, so at this stage, I'm really not into solving this for you. And if you really think about why I'm not planning on solving this for you, is look at the format of this problem, right? Look at the format of this problem, and then look at the format of the one that we just did in number 88. They're exactly the same format. So just look at how I did 88, and then pick up from here. I just wanted to show you this additional step in number 90 that you need to do. And I promised you to show you why, but basically, because there's a 2 out front, if you were to be adding b over 2 squared, that is assuming that there's a 1 out front. So then that would mean you have to multiply everything by 2, which makes things a lot crazier. So it's just better to divide out by 2 at the beginning, and it's your safest bet. Otherwise, you end up with the wrong answer, and then it's really frustrating to go pinpoint your mistake and stuff like that. Now, the third way of solving quadratics, quite honestly. So let's just, because we're coming to the end of this extremely long lesson, as far as how to solve things is concerned. So you realize that when it comes to quadratics, right? Quadratics, ax squared plus bx plus c equals 0. There's just so many ways to solve it. But one of the ways to do it is through factorization. It's the easiest way to do it. Unfortunately, it doesn't always work because you can't always find those factors, and sometimes there are factors where you can't think of them, right? So then the second method that we learned is called the square root method. All right, the square root method, and that's only if things work out perfectly for you. Then another method that we learned is called completing the square method. Okay, that one nobody likes because it's just really, really difficult, right? But like I told you, you need to know it though. Okay, and then there's the quadratic formula. All right, so quadratic formula is yet another method of doing the same exact process of solving a quadratic equation, right? Now, I know that we've been through the quadratic equation a number of times this year, so I'm not gonna pick some of the beginning examples. I'm gonna pick some of the latter examples to try with you, just to make sure that you're comfortable with these answers right here. So let's take a look at number 98. All right, let's try number 98. I guess what's a little bit different here is it's got t's in it, right? And one thing that I'll let you know is notice how factorization wouldn't even work for you. If you multiplied 1 and 4, you get 4. You don't know how to factorize that, right? Because you can't find anything that adds up to a 1, right? So you need the quadratic formula, all right? So the quadratic formula says x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. All right, we've been through that time and again this year. Now you need to adjust that for what you have. A is 4, b is 1, c is 1. Furthermore, notice how they're solving for t. I guess that's what's so super different about this problem, right? Just so you get comfortable with other variables. In calculus, it's not always an x. Sometimes it's a different variable. So t is equal to, now negative b would be negative 1, plus or minus the square root of 1 squared minus 4 times 4 times 1, like that. Okay, and you divide that by 2 times 4. All right, so you're going to find something very interesting in this problem. It says negative 1 plus or minus, and on the inside of the square root you end up with 1 minus 16, and 1 minus 16 is negative 15, and that divided by 8 is a problem. And the problem, if you haven't realized it, is you cannot find the square root of negative 15. You're welcome to pick up a calculator and try finding the square root of negative 15. No such number exists, right? It's ironically not until the end of pre-calculus that you learn how this can actually be solved. But for now, they said find the real solutions, and so you answer back and say there are no real solutions. Okay, so that is something that's possible, and I wanted to show that to you firsthand. Number 100, I won't do the whole thing because, I think that might be a little bit excessive. But what I just want to remind you of, and this messes up students all the time, is they don't make sure it's in the proper format. Remember, the proper format for quadratics is you have to have ax squared followed by bx followed by c if it's available, and you got to set it equal to 0. So what's the problem with this is, notice how everything is jumbled up. So you need to bring the 1 and the negative 2x to the left side. So it becomes 2x squared plus 2x minus 1 equals 0. And then you go about your way of solving it using the quadratic formula. Okay? All right, let's try number 102. So 102 is the interesting one. I don't think let's use an a value of 1, a b value of root 2, and the c value of negative 2. Here goes the quadratic formula. X is equal to negative root 2 plus or minus the square root of b squared. So I'm going to put parentheses around this. So b squared minus 4 times a times c. So as I said it, I wrote down each of the numbers, right? and then that's divided entirely by 2 times a, which is 2 times 1 in this context. Okay, so the one out front, negative root 2, you can't mess with it, all right? But what's so interesting is on the inside, you end up with the root of 2 squared, and the root of 2 squared is actually 2, all right? So let's take an extra step just to kind of address this issue. So you end up with 2, and then this you guys know how to work with. Negative 4 and negative 2 make a positive 8, so 2 plus 8, like that. And on the bottom, you end up with 2, all right? Now, you're going to end up with negative root 2 plus or minus the root of 10, which cannot be simplified, divided by 2. So, in fact, we actually have two answers to this question. The first answer is negative root 2 plus the root of 10 divided by 2, and you have x is equal to negative root 2 minus the root of 10 divided by 2. All right, so one of the reasons why the quadratic formula is one of the most famous and most popular formulas in all of mathematics is because even when factorization fails, the quadratic formula is still there to answer pretty much any question. Okay, so it's an amazing technique which I've learned time and again, so it's not something that I need to spend a whole lot of time on. All right, now let's go to the last objective of this lesson. And in the last objective, basically initially students tend to struggle with this because they don't understand what it's really asking, I would argue, right? Once you learn what it's asking, you're like, oh, this is actually a lot easier. Okay, so basically what you got to do is pretend that A, B, and C are just constant numbers, right? Let me give you an example. So notice how number 110, because I was about to do that in just a moment, right? So take a look at number 110. You see where it says A and B? Pretend it really said, and I don't want you to solve the problem this way, please, right? I'm just telling you pretend, right? Pretend it said 1 minus 5x is equal to 7. Yes, so I basically changed A to 5, and I changed the B to a 7. It's just saying, how would you solve this equation? Well, you would have told me, well, I'm going to bring the 7 to the other side, so this becomes a 7 minus 1, and then I would divide by negative 5 on both sides, so that would become a 7 minus 1 divided by negative 5, whatever that answer may be. So that's exactly what number 110 is asking. It's saying, if you have 1 minus ax equals b, tell us the process by which you would solve this. So what would you do? You'd say, well, I'm going to bring the 1 over, so it becomes negative ax is equal to b minus 1. Then I'm going to divide on both sides by negative a, like this over here, so that a's cancel out, just like the 5s would have canceled out. And there you go, I have my answer, b minus 1 divided by negative a, like that. Okay, I want to address one thing. You guys, when you have a negative symbol, look, you can put the subtraction sign in front of the fraction like this. That's acceptable, all right? You're allowed to do that. That's algebraically true, okay? You're allowed to take the negative symbol, put a parenthesis around the b minus 1, and then write a. You're allowed to do that. Now, let's take another question here. I'm going to take number 114. And in number 114, just pause for a moment, okay? If you're getting overwhelmed by this, going like, wait, I don't understand. What does that stand for? Just pretend these are all numbers, okay? Just pretend A, B, and C are all numbers. And you did this in part 1. That's how easy it was. You did this in part 1 of solving equations. What would you do? All right, so let's go ahead and get started. For me, these are actually kind of entertaining because it just helps you solve equations, and I could solve equations all day and not get bored by them. So you have b minus c over x minus a. Now what would you have done? What I taught you is this is whenever you have a proportion, i.e. you have a fraction on one side and a single fraction on the other, the best method to use is to use the technique of cross multiplication, all right? So we're going to go ahead and cross multiply. And in cross multiplying, we're going to multiply the b plus c and the x minus a, i.e. this comes up this way, and that goes up that way, okay? And the b minus c times the x plus a, like that. All right? Now what are we going to do? The next thing that we need to do is use the FOIL method. Okay, so let's go ahead and get started. B times x is bx. B times negative a is negative ba. Or you can call it ab because that's more appropriate because it's alphabetical, right? C times x is cx. And then c times negative a is negative ca. So all of that is the left side of this equation. Now do the same exact process with the right side of the equation. On the right side of the equation, you end up with bx, a little quicker now, plus ba minus cx minus ca. All right? And then, this is the end of this very important lesson. So what have you picked up in this lesson? One thing you've picked up is whenever you have the same term with the same sign on either side of the equation, they're as just good as gone. So bx and bx are gone, right? What else is going to leave? CA and CA because they're both negatives. And remember the logic. You're welcome to move them over to the other side, but you'll notice that the sign switches anyway, and then they cross off, right? However, we still have a problem here, all right? We've got a negative BA plus a CX on the left side, and you've got a BA minus a CX on the right side. What are you going to do? What has your teacher always taught you to do? Because I'm not necessarily teaching you anything new here, right? Well, you've learned that you got to group everything that's got an x onto one side, right? So let's move the negative cx to the left side, make it a plus, and let's move the negative ba to the right side, make it a plus, right? So you end up with cx plus cx, which is 2cx, right? And on the right side, you end up with ba plus ba, which is 2ba. Now, what's the last thing that you would need to do to solve this equation? You would need to divide by 2c on both sides. And so when you do that, you get this really cool looking thing. Basically, the answer is x is equal to a simplified ab over c. I don't know how they think of these problems. It's very entertaining, though, how they do that. I don't know. Maybe the person sat down with a solution and said, let's make the question look like this, but that's the answer. The answer is a times b over c. Now, I'm going to use some things that you're going to have to encounter in your time in high school as well as in college. So inshallah, you can thank me later for this. And so these are questions. But basically, these are all popular equations, and your job is to essentially solve for a particular variable that they're picking for you. All right. So 1 over r is equal to 1 over r1 plus 1 over r2. I'm going to give some space. Actually, you know what? Let's just write it first. Like that. Okay. And this is actually a formula for something called the resistance in a circuit. This is used in physics, and it's used in engineering as well. But regardless, as a mathematician, what's your job, right? You're like, okay, well, you just gave me a fraction equal to another fraction plus another fraction, and my math teacher taught me that you need to find the least common denominator, right? So the least common denominator of r1, and r2 is r1, and r2, like that, all right? And then what the technique we're using is called multiplying by the LCD method. So go back to the previous lecture if you'd missed it and discover again how do you use the multiplying by LCD method. Like I said, we're not learning anything new today, we're just applying stuff that we've already learned. So now, in the left fraction, what we're going to do is we're going to multiply it by the LCD. So r1, r2. I keep saying r1, r2. It's really called r sub 1, r sub 2, like that. It's just too much in the month of Ramadan to say it that way, though. So 1 over r1, and then that's multiplied by r1, r2. All right. Oops, sorry. And then the last one is 1 over r2 multiplied by r1, and r2. Okay, so just following the rules that we learned in the lesson. Now notice how the r's will cross off. So you'll be left over with r1 times r2. Now notice how the r1's will cross off. So you'll be left with r and r2. So these are all unique. They're all different than one another, okay? Even though they're R's, look at the subheading on them, right? And finally, in that last set, you'll cross off the R2s, and so you'll be left over with R and R1. So R and then R1. Now, the question is, what are you trying to solve for? And what you're really trying to solve for here is you're trying to solve for R, all right? So what are you going to do to actually solve for R? Basically, on the right side, notice that you can find the R over here as well as over here, all right? So the technique that we use, is called factorization. And in factorization, you say, I'm going to factorize out that R, and I'll be left over with R2 plus R1, like this. And on the left side, I'll have R1 times R2, like that. So what's the last step that you need to do? You need to go ahead and divide on both sides by R2 plus R1. And when you do that, it's going to cross off the R2 plus R1, and you have found a way to solve for R with everything that you had, R1, R2 over R2 plus R1, right? So crazy stuff right there, but it actually does work out for you, okay?